All right, so we're in our second day of review for the final, and I want to start you off with piecewise functions. These functions are two-part functions, or sometimes three-part. Why isn't it just x squared? Well, it is, kind of. The way I'd start this is by making a little sketch. Everybody do this with me, please. Make a little sketch. And you know what x squared looks like. I'd put it in a dotted line, kind of like that. Then I have to put on this other graph, absolute value. Oh, that's right, those are the V-shaped thing. And the V-shaped thing is moved 2 to the left. So instead of starting right at the origin, it starts like over here. And it's got a kind of a V-shape going like that. I should have done that in the dotted line. Let me undo that. And there we go. Okay, dotted line. Now, where does the rubber meet the road? It's, do you understand this part? Where x is greater than 0, that's where it's x squared. So that means on this right-hand side, it's only this. So I'm going to darken it in now in black. It goes like this. At 0, is it actually this function? Nope, because it says greater than 0. So this is an empty spot right here. That is crucial to understand the endpoints. Now I see I got two functions going on the left side. Can't have that. It's one or the other. And which function is it when you're left of 0? The absolute value one. So I have to get rid of the blue one. So I'm going to try to use a really small eraser here and see if I can surgically erase just the blue stuff. There we go. That's pretty decent. And then I'll finish that up to there. And is it a darken in spot? Here it absolutely is, because it was an empty spot on the other one. And then it goes forever this way, forever that way. I'm going to fill these in with solid lines. And there we go. Does that ring a bell? You remember piecewise? Okay. So they're not too hard. Yes? In real life, where would you use this? I would just give you an example that you could probably have a profit function that's one type of thing in one part of the year and something else in another part of the year. Like, let's say your business runs, I have a buddy who does lawn mowing and he does snow removal. The lawn mowing he does per time, like every time he mows it he gets paid. And the snow removal he gets paid by the month. So he might have one function for this part of the year, okay, because it's how many times he mows makes the difference. But in the winter, it's pretty much a straight line because he just gets paid every month. No matter whether it snows or not, he gets paid like $100 a month and he will take care of your driveway. See how it could be two different things, two parts of the year? That's an example. Okay, now would you personally do this if you were the snowplow guy? Would you draw it on a graph and all that? Maybe not, but it's just a way you could describe it. All right. Sketch a transformed parent function. So this one is a picture. Make me a sketch. Just a quick sketch. It can be rough. You should be able to say, okay, I know what those kind of look like. I know you stretched it. I know you moved it. Try to figure out where it should be. This is a typical final question. One of the easier ones, actually. Now remember, the order of these things matters. Sometimes it does, sometimes it doesn't. Just like in some math problems, 2 plus 6 plus 8, the order doesn't matter. But as soon as I throw in a parentheses and a minus, now the order does matter. If I don't do it in the right order, I won't get the right answer. All right. Especially if I change that to like a divide or something. And then I make this squared, and I can change the order around and have like 6 different answers depending on what order I do them in. Okay, so point is, what have I told you about order? I suggest you start on the inside. So I would take my parabola and move it where? Left 2. So my parabola is now over here. I'm in the wrong spot, sorry. Over there, right 2. Okay. And now I'm going to have to do that 3 and that 4. What's the 3? And that's the one I do first. So it's stretch of 3 times taller. So basically it's going to look kind of like this. It's like somebody grabbed the ends of it and stretched it up. All right, because the heights are now 3 times taller is what they used to be. then the last part is the minus 4, which is down 4. So I grab my little new parabola, move it down 4, and that's about right. Is your sketch about where that is? Good. Now, what if you did it from the outside in? Remember I was telling you that some of the other teachers encourage kids to do it either way. Well, then, you could start on the outside and say, all right, I should make it 3 times taller in the first place, so that would be here. That's the normal parabola, except 3 times taller. Then you go and do the minus 4, which is 4 down. And then you do the right 2 thing. We ended up at the same spot. So it's okay to do it from the outside in or from the inside out. I personally like inside out because most math problems go that way, but either way works. All right, now for review of that. Next thing, word problems. Projectile motion. We talked about it yesterday, but then one of the questions came up that stumped a lot of people. It was, okay, you got the graph, and it looks like this, and they got it, you know, wait, it wasn't like that, actually. It was upside down from that. They sketched the graph, and it looked like that, and then it said, when was the ball, or whatever the thing was, above, like, 80 feet? And they were trying to put that 80 feet height in for x. What's wrong with that? Height is y. Yeah, it's not the x. So how do I put in 80 for y? You write y equals 80, and you might realize, oh, well, that's a line. Y equals 80, right? So I can just graph that in there too, and all of a sudden, how do I know when it's above that line? Well, it's going to be above that line from here to here. It's above that line. Okay, so you just put in another line in your graph. When they ask you for above 80, you say, well, y equals 80, and figure out when it's above that. What if they had said time was 8? That is an x. And then you can use that value thing on your calculator. Second, calculate the value, and it has a little x with a blinky box, and you can drop in an 8 there, and that works because time is on the bottom. This is usually like a height. All right. Now for the projectile motion. How about the box with a corner cut out? Man, if we haven't practiced those enough by now, I'd be a little scared. But I want to bring up a quick topic. You remember how they kind of look like this? Corner, corner. They're all the same. X, 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 and X. And if this had been 20 and this had been 10, would you just write me the formula for the volume of this box? And then I'm going to ask you a poignant question about it. Right. Volume equals. That's an appraiser from Duluth, Minnesota. All right. Volume equals. Length times width times height. Because Mr. Server always told me to start with the original formula. Then put in what you know. All right. Volume is length 20 minus 2x. We usually use the longest one for length. Width 10 minus 2x. And the height x. There it is. So since you got a calculator on this test, you certainly can use the calculator. And what would you do with it? Well, you might graph that. What if I asked you for like the maximum area or something like that, or the maximum volume, sorry. You'd look for the highest spot on the graph. But what if the graph keeps going up and up and up and up? Then you got to know what is the domain. What are the things that could work? Do you agree I can't have x be negative? Okay, so it's got to be from 0. Can it even be 0? No, then we're not cutting anything out. So it's got to be bigger than 0. And then what's it got to be less than? You look at the smaller dimension here, and you say, if I cut out corners that were like 6 long, it wouldn't work, right? Because I wouldn't have enough. So 5, yeah, between 0 and 5. Do you get how the domain between 0 and 5 is important? Because now if I want the biggest box I can get, I mean, of course, you know, at some point, the biggest box that you can get depends on how big the sides can be. All right, so if I graphed this puppy and I looked at the graph and it was like this rising line, I'd need to know when to stop. Well, if the smallest it can be is 0, I go from here to, let's say, the biggest it can be is 5. I go to like here. Well, then you pick the one that gives you the biggest one. All right, but the point is that sometimes that domain matters. Again, if you got two answers, one of them was 7 and one of them was 4.4, which would you pick? 4.4, because 7 can't work. It's not in the domain. So you will a lot of times get more than one answer, and they'll a lot of times put like that as a multiple choice, so that you got one of those where you're giving them an answer that seems right, but then it won't actually work in the problem. And they'll have that as one of the, like A. You notice it right away, and you're like tempted to be sucked into that answer. Be careful you don't get fooled by giving them an answer that's actually extraneous. Okay. Oh, wait. There was one other kind, maximizing the area of a rectangle. We've just done those for our last test, so it seems like something that's probably as fresh in your mind as possible. So I don't think we need to do anything other than, if I gave you this rectangle and I said this was X, and I said the area was 20, what would you put here? Not, no, if the area is 20, it would not be a 10 involved. What do you think? 20 over X. If the perimeter was 20, then it would be 10 minus X. That would be the other kind of. Okay. Moving on. Vertex form of an equation. That's in vertex form. So what's the vertex? Should be able to pick it out of there like that. Does that ring a bell? That's the vertex. So if I was going to graph this thing, I'd start there. And then I'd move it over 1 and up 1, except, wait a minute, oh, it's got a stretch factor of 3. So I'd go over 1 and up 3, etc. All right, next topic. If I was going to sketch this graph, it'd be really handy to know what are the places that it touches the x-intercept. It's also known as the zeros or the roots. Okay, sketch this with me. Back with me. All right, to sketch this, I need to know the roots, the zeros, the x-intercepts. They are at 1 and -2 and -3. So here's 1, here's -2, and here's -3. Put dots there. So it's definitely touching at all those spots. Those are the zeros. That's what they do. Okay, now, are they all bouncing? Is any of them bouncing? Now, one of them's bouncing. Now, to decide how it bounces, whether it bounces from the bottom or from the top, I need to know, is it gonna, how does the whole thing end? Does it end going down or does it end going up? Up, because it's positive in front, there's no negative there. That means it's going up at the end, which means since that's a cut-through kind, see this doesn't have a squared on it, so it's a cut-through, it must go down like this. And it has to bounce at the -2, must bounce like that, and then it has to cut through on the end one. Now I did that one. Does it make sense? The only other thing that I could check that would be really smart to check would be this spot right here. How low did it touch? I don't know. I just made that up. But could I figure out what the y-intercept is? Yes, I could. Answer this. Finish this sentence. The y-intercept is where x equals 0. So I could just stick in 0. Everybody stick in 0 quick. In your head. And then maybe a little bit on paper and figure out what's the y-intercept. Don't say it. Stick in 0. Figure out what the y-intercept is. Did you get a negative 2-digit number? Raise your hand if you think you know what it is. All right, what do you think? You are correct, -12. I stick in 0 here, and here, and here. -1 times 2 squared is 4, times 0 plus 3 is 3. Multiply them out to get -12. So that it didn't look like I went low enough. Maybe I should have put it down like there. All right, now I got a pretty good idea what this graph looks like. Now I should probably ask this question. Both ends are going up. Is that the way it's supposed to be? Yeah, because this is a degree 4, and both ends should be going together, right? All right. Does this bring back a bunch of stuff? I hope it does. That's stuff you got to know how to do. You try graphing that one quick then. Make me a little sketch of what that puppy would look like. If this was a multiple choice part of the test, they'd probably give you 4 different graphs, and you pick out which one could be right. And you'd be looking for things like, does it end right on the right side? hope you knew that 2 and 4 were the important spots here. And I hope you knew it ended going down. And it was a cut through at 4, so I can go like that. Next thing, logically, is if this one's a squared, that means it's a bounce at 2. Boing. And now, what did I tell you to figure out in the last one that would be smart to figure out here, too? The y-intercept. The y-intercept is where x is 0. Quick figure out what this would be if I stuck in x was 0, so I can know where it touches along here. Is it like right there, or is it up fairly high, or 0, 0, negative. Negative 2 squared is 4. Minus 4. 4 times 4, positive 16. Negative 4 times negative 4 is positive 16. Okay, so it touches at positive 16. So holy cow, this is, it touches like way, way, way up, way up. So this is a very steep line is all that's saying. Does your sketch look kind of like that? All right. Next topic. Find the domain. The domain means what numbers work. You start out with the assumption everything works except there's a couple things that probably won't. So give me something that won't work. 0. What else won't work? Negative, sorry, 3, positive 3. So how do you keep track of all these things? Well, you make a number line. Everybody, make a number line. Don't have to write the problem, just write a number line. Put an empty spot at 0, because 0 doesn't work. Put an empty spot at positive 3, because 3 would also crash it. But how do you handle that square root thing? What's the important number to put on the number line there? 5, because 5 will be the crucial turning point. But it's important you realize that 5 actually works. Because see, 5 minus 5 is 0, and the square root of 0 is 0. It's not a weird number, it's 0. And 0 over anything is 0. So bottom line is, it works there. So often people get that part wrong right there. All right, so 5 actually works. Now, I test all my intervals. And this time, it's just like when we did our sign chart where you wanted to figure out if it's positive or negative, except in this case, we just want to know, does it work or does it not work? And you can put like smiley faces where it works and frowny faces where it doesn't work. If you tested 4, you'd find out, what? What do you think? Work or not work? As soon as I put a 4 in there, I realize it doesn't work. Frowny face. Doesn't work there. Ooh, that's a really frowny face. It's like a melted frowny face. There. How about 2? Does 2 work? Nope. Anything small that goes in there is not going to work. So that doesn't work, and neither does this. Does anything work? What? 5 itself does. And how about things bigger than 5, like maybe 6, 7, 8? Let's check one of those. Let's try like 8. If I put in 8, they're going to have a problem under the root? Nope. Is it okay to have 8 minus 3 is 5? Yep, that works. And 1, 8, yeah, that's okay. It works out there. Final answer is from 5 to infinity is the domain. All right. Stay with me. Almost done here. Find me that domain. So I do hit that. Once we're done, you'll have a lot of work done. Just keep with me. Everything works except, and find those key points. Negative 2 would be a problem, and 4 would be a problem. Mr. M, does it work at negative 2? Does it work at 4? Does it work between negative 2 and 4, like something like 0? No. Agreed. Does it work like at 5 or bigger than that? How about down here in the really small negatives, like negative 20? Nope, because this would crash it right there. It would be a negative under the root. So, final answer is it only works from there over. 4 to infinity, bracket or parenthesis? Parentheses. All right, next kind. That was find the domain. This is find the range. These, we really pretty much gave you pictures, unless you could draw the picture, you know, like you had a calculator. And do you have a calculator on this test? Yeah, so any range question you pretty much can do with a picture, because you can graph it. So if I drew this one for you, do you guys, I hope you have this memorized. It looks kind of like this. This is the key spot, and then it gets closer and closer, never touch, closer and closer, never touch. Key spot there, same deal. Remember that one? So what's the lowest? The range is from the lowest it goes to the highest it goes. What's the lowest it goes? Negative infinity. Up to 0. Very good. Because 0 it doesn't work at. Then it starts working again at 0, goes to infinity. Remember how to do those range problems? You just ask yourself, where does it work as I go from down to up? Is there any spots where it doesn't work? Yeah, it doesn't work at 0. All right, so what's the range of that? Just in your head, think about where it would be. It would be the same graph except shifted a little bit. So from negative infinity up to negative 2. Very good, because the whole thing is shifted down 2. So these graphs are like down like this. And so it's from negative infinity to negative 2, and then negative 2 up to infinity. All right, next kind. This is actually off of your packet. I want to do one with you. Take your yellow packet, turn it to problem 4B. If you've already done it, awesome, check it. But if you haven't, you might want to get going on it. My expectation is that by Tuesday, the day we come back from the long weekend, that you will have 3/4 of this packet done. And I will be grading some stuff on Tuesday accordingly. So in other words, yeah, we can check the first, 2, 3, I don't know, 4 pages at least of this thing on Tuesday. So you have some work for the weekend. Get her done. Okay. 4B, I'm doing it with you. First thing, if they're asking about domains here, which they will be, then we need to know the domain of each function. What's the domain of f of x? It's really easy. Everything works except, so you'd write all real numbers except x cannot be negative 1. That's the way I like to write them on this kind of a problem. Yeah, you could write it with parentheses like negative infinity to this, but write this in 4b underneath f of x. All right, then underneath g of x, what's the domain of that one? All real numbers. Nothing will fail because there's no denominators to screw up and there's no square roots to screw up. So it's all reals. So what's the domain of f plus g? This is the kind where you just graph the one domain, graph the other domain, see where they intersect. You remember that? So if I graph this one, it's all real numbers except x is negative, can't be negative 1, so I go like this. Actually, wait, that's all real numbers. Then the other graph is all real numbers except x cannot be negative 1, so here's negative 1, empty spot there, all the rest of it. Where do those overlap? Pretty much the black one is the one where they overlap. There's an empty spot at negative 1, so my final answer would be all real numbers except x cannot be negative 1. All right. What's the domain of f of g of x, also known as FOG of x? They might have it like this on the final. They might have it like this on the final. Do you remember there's a big, nasty formula for doing these? This is worthy of writing down somewhere where you can review it the day before we take the test. Write this down. D of g, do you remember this? Anybody recite it from memory? Intersected with, good, g of x in d of f. Very good. If you had forgotten that, write it down and then remind yourself right before you take the final, because once you know this, it's not bad. You just plug in the numbers. Well, let's look back. What is d of g? I look at my thing. It says d of g is all real numbers. We're actually doing one of your problems right now. Problem 4b asks you to do the domain for f of g of x. All right, so it's all real numbers intersected with g of x in d of f. G of x is that one, this one, in d of f. Okay, so I got to put that into, that's d of f right there. So I got to put x squared minus 2 into the x part here. I'll make it an empty spot. And then say is not equal to negative 1. And then I solve that. Add 2 to both sides. Then I square up both sides. What do you get? Yes, square root of 1 is 1, but what's the other part? Absolute value. Thank you for remembering that. And x is not equal to plus or minus 1 then. It's so easy to forget the plus or minus because you forget the absolute value. All right, so how does all real numbers intersect with that? Well, pretty much, the answer is if you overlap them, you make one number line, it's going to be all real numbers, and the other number line's got some holes in it. The one with the holes in it wins. It's the overlap. So the answer is this. All real numbers except x cannot equal plus or minus 1. All right, I know it's hard to concentrate. It's a Friday, and it's warm in here. We're almost done. Turn to number 13 in your packet. This one is write it in vertex form. You got to use the plus box, minus box thing for this. Do you remember that? If you don't, you might want to follow me in doing it. You rewrite this with plus a box and minus a box in the right spot. Negative 2x squared plus 8x plus a box minus 3. You might want to get started writing unless you've already done number 13. Okay. Mr. S, are you still with me? Number 13? You already got that? Awesome. Sorry, you were so fast then. So I looked up and there was no pencil moving. All right. So then I'm going to factor out some stuff here. I'm going to factor out this negative 2. And then I have x squared plus, no, it's not going to be plus. It's going to be minus. What's it going to be? By taking out a negative 2? What? Minus 4x plus a box. I leave the boxes alone. Now why did I do that? Because I want to get this to be a plain old x squared. So I factored out that thing. Now I can do my half and square. The little German boy tells us what to put in here. Half of the 4 is 2. 2 squared is 4. Half and square. You've done it again. And then this little thing needs to go here. So easy to forget that. I've forgotten it like 6 times as a math teacher. Probably more than that. Seriously, it's just you're in the middle of this process and it's just not natural to remember to bring this over here. Okay, final answer, negative 2. 2 sets of parentheses that are identical. That's the point of this whole thing, is this is making it complete the square. X and a minus 2 and a minus 2. And then negative 2 times negative 4 makes positive 8. Positive 8 minus 3 makes positive 5. Almost done. Now why is that good? Because I can see the vertex staring back at me. Now, what's the vertex? 2, 5. So I now know the vertex, even though there was no way to know 2, 5 was going to be it by looking at that. But once I'm done with this little process, I can see the vertex is 2, 5. All right. That was problem 13 off your packet. I have done everything that I think you can possibly hold for one day. You got to study over the weekend. You come back with 3/4 of this thing done on Tuesday, and the whole thing done by the time we take the final. Am I going to care? Yup. If you are a slacker right before the final and I collect these packets and I have a judgment call on which way to push your grade for the semester, I will only give you that benefit if I know you have been trying hard, which implies doing your review for the final. Okay, so don't be asking me for any kind of break unless you've showed me a lot of effort on your part. Okay, if you need help, I'll be here, willing to help you. We got about a good 15 minutes left, so